The next couple of problems are going to need some formulas. So you need to know what the area formulas for a rectangle and a triangle are. So on the rectangle we have area equals base times height or length times width. Depending on the verbiage that they use, it's basically the same thing. And then the triangle is the area equals 1/2 base times height. Okay, so 1/2 times the base times the height includes this fraction right here. And a lot of times students don't really like to have fractions in their problems. So if you multiply both sides of the equation by the LCD, which is 2, you get this formula here. 2 times the area, so you multiply both sides of the equation by 2, which gets you 2 times the area, and then the 1/2 times 2 goes away. This area formula right here is the same as the first area formula for the triangle, but this one includes no fractions. So I'm going to use this one on our triangle problem to show you that you can use it without fractions and you don't have to worry about getting those yucky fractions out. So the first problem is the area of a rectangle is 28 square feet. The length is 1 foot less than twice the width. What are the dimensions of the rectangle? Okay, so step 1 tells you to define your variables. So I'm going to let x be equal to something. I do know that I have length and width, but I don't know which one should be which. So I'm going to keep looking for the comparative statement, and it looks like the second sentence is the one that's being compared to. The length is 1 foot less than twice the width. The length is being compared to the width. Who's x? Well, x is going to be the width because that's the one that's being compared to. Now I need to know the length, so let's go ahead and read that comparative statement and see if I can't write an expression for it. The length is, okay, length is, I got that. 1 foot less than, what does that than tell you to do? Switch the order, so it's going to be something minus 1, less than, so twice the width, less 1. 1 foot less than twice the width means twice the less 1. Okay, so step 2 says draw a picture. All right, we finally have an opportunity to draw a picture. So I can now take my rectangle. My width is x. My length is 2x minus 1. And then I also know that the area of the inside is 28 square feet. So that's the inside of your rectangle. Step 3 says to write an equation. All right, well, I have to have the area formula, and the area formula is area equals length times width. And my area, it looks like, is 28 from my problem. So I'm just substituting that in. Equals my length, which is 2x minus 1, times my width. Now, putting the x in the back looks a little weird. So we know multiplication is commutative, so I'm going to go ahead and put that in the front just to make it look a little bit easier when I distribute. Step 4 says to distribute and solve. So I have 2x squared minus x equals 28. I'm going to subtract 28 on both sides. And that gets me 0 equals 2x squared minus x minus 28. Now at this point, some people don't like this 0 in the front. If you are one of those people, you are welcome to put it in the back, because the placement of the equals 0 doesn't really matter. If that makes you feel better to have it in the back, by all means, go ahead and do it. I'm not sure if this factors, but I'm going to go ahead and try. Okay, so I'm going to try 1x and 2x. I'm going to try 4 and 7. I don't want to put the 2 and the 4 next to each other, so I put them across from each other. And I'm getting 8x and 7x, and I'm trying to find a negative 1. I certainly can't find that, so I'm going to put that in there. If you prefer the AC method, go right ahead and use AC method. I have no problem with that. Okay, so then I'm going to set each of these factors equal to 0 and solve. X equals 4. And x equals negative 7/2. Whew, that was a long time ago that I told you what x was, right? So good thing we wrote it down, because I've forgotten which one was x. But because I've written it down, x is width, we are talking about widths here. We have two solutions for the width, 4 and -7/2. Well, do you see a problem with one of those? Have you ever known a width to be a negative number? No. Widths are not negative, so we're going to cancel that value out. That doesn't actually even make sense. Please note that I'm not canceling that out because it's a fraction. I'm canceling it out because there's no such thing as a negative distance. So I know that my width can only be for somethings. What is it? Feet? Inches? Feet. Okay. So we're talking feet. So make sure you put your unit on it. But I haven't actually solved the whole problem because I didn't find length yet. We know that length is, let's see, 2x minus 1, which is 2 times x, but my x is now 4 minus 1. So that's 8. 8 minus 1 is 7. So my length is 7 feet. This is what I believe my answer to be. Notice on step 5, we needed to answer with units. We did. We put feet on it. And we're going to go ahead and check. To check, on step 5 here, go back to the words and make sure every sentence makes sense. The area of the rectangle is 28 square feet. Well, is 4 feet times 7 feet, is that 28 feet squared? Sure is. Is the length 1 foot less than twice the width? Well, let's see. The length is 7. Is that 1 foot less than twice the width? Yeah, 8 minus 1 is 7. Okay, so the second sentence also makes sense. The third sentence says, what are the dimensions? And I have answered that, so I know that I am completely done. The height of a triangle is 1 inch more than 3 times the base. Find the base and the height of the triangle. So our first step says let's define a variable. So I'm going to let x be equal to something. But because I'm looking for both the base and the height, I'm not sure which one's which. So in order to find out which one's which, I need to reread it and see if I can't find the comparative statement. The height of a triangle is 1 inch more than 3 times the base. Okay, this first sentence happens to be comparing the height to the base. So now that I have my comparative statement, the height comes first and it's being compared to the base. So we're going to let x equal the base. Now once we have that comparative statement highlighted, let's figure out what the height is. It says the height of a triangle is 1 inch more than, what about that than? It switches those order, doesn't it? So 1 inch more is going to be plus 1. 3 times the base, that's going to be 3x. Alright, so now I've found my variable. Alright, step 2 says I can draw a picture. So I've got a triangle here. My height is right down the middle. My base is at the bottom. It says my base is x, so x goes from here all the way to here. And my height is going to be 3x plus 1. Maybe I didn't draw my picture to proportion, but that's okay. I got my picture down. Step 3 says to write your equation. Well, in order to write an equation with areas, I need to have an area formula. As stated above, I'm going to use 2 times the area equals base times height instead of area equals 1/2 base times height. I could have used either one, but I prefer the first one because this one has fractions and nobody likes fractions. So when I plug this in, I have 2 times a, but who is my area in this particular problem? Well, it says the area is 5 square inches, so these are all going to be in inches. So my area for now is 5 equals my base. The base is x, and the height is 3x plus 1. Excellent. Now I have a formula. Next, I'm going to solve. So I'm going to distribute this 3x squared plus x. subtract 10 on both sides, which is going to get me 3x squared plus 10x minus 10 on the right and 0 on the left. Now again, if some people, it doesn't really matter where the 0 goes to me, but some people don't like the equal 0 on the left. They really prefer it on the right. If you're one of those people, just pick it up and move it. So let's see if this factors. I hope it does. So I'm going to try 1x and 3x. I'll try 2 and 5. That gives me 6x and 5x, and I'm looking for 1. With one of each sign, can I get to a positive 1? I think so. A positive on the 6 and a negative on the 5. Make sure that you're putting it on the bigger product, not the bigger number inside, but the bigger product. So this factors into x plus 2, 3x minus 5. Set each of those factors equal to 0. So I have x is equal to negative 2 and x is equal to 5/3. Okay, now that was a long time ago what we talked about what x was. So it's a good thing we wrote it down. X is my base. So both of these are potential bases, but there is one problem with one of them. And the problem is the negative. There is no such thing as negative 2 inches. We don't measure in negatives. So I'm going to take out the negative one that doesn't actually make sense. Notice it's not the fraction, okay? I'm taking it out because of the negative. A lot of students are like, oh, fractions don't make sense. Yes, they do. They're numbers, okay? But negative distances, that's what doesn't make sense. So I believe my base is 5/3 inch. Now the question said both find the base and the height, so I need to figure out what the height is as well. So my height is 3 times x plus 1. And my x is 5/3. Now this is awesome because my 3's divide out, and I am left with 5 plus 1, or 6 inches. Okay, let's go back and check. That was step 5. Is the height 1 inch more than 3 times base? If I take the base, which is 5/3, times it by 3 more 1, that gets me 5 plus 1, or 6. Okay, so the first sentence makes sense. The second sentence says find the base and the height if the area is. So if I need to take my area, which is 2 times 5, which is my formula, equals my base, which is 5/3, times my height, which is 6, I want to make sure that this works out. Which gets me 10 is equal to, what is that, 30 in the top over 3. Look at that. 30/3 is 10, so that means my base and my height are correct. So I have successfully solved for the base and the height of this triangle.